So, as part of the forecasting, there are multiple methods to calculate or estimate the forecasted value. So, first one, the very simple one is naive method. So, it is like taking the previous value itself as a forecasted value. So, for this period, for period 17, the forecasted value of this one is as simple as taking the previous value, the exact value. So, this is naive method, and in case if we want to go for the period specific, like quarter specific forecasted value, it is going to be considering that particular quarter. What was the previous value that is existing? In this case, it happened to be the same value 550, but otherwise we will be considering the same quarter one. So in case of quarter two, if we want to take based on the seasonality or XYZ reasons, then the value will become 550. So this is simple naive method, and another simple method of calculating the forecasted value is taking a simple average. So there are totally 10 values existing. At the time we started doing the forecasting. So average of all these 10 values is our forecasted value, which is 280 over here. But after, at the end of period 11, we found that this is the actual value. So now, based on this information, this available information, we are going to forecast the new period value. So that is nothing but 280 multiplied by 10, which was the average of 10 values, plus the new value that we found out, that is 302 divided by 11. So this becomes the new forecasted value of this one. So at any point of time, it is very rare case that the actual value and the forecasted value will be same. So the difference is called error. Error equal to actual minus forecasted value. It can be positive or it can be negative, but the difference is called error. Another way of calculating a forecasted value is a moving average. So in this one, there are multiple moving averages that we can take. One is 2 period moving average, 3 period moving average, 4 period, 5 period, like that, and period moving averages we can take depending upon the availability of data. In case of 2 period moving average, what we do is take the previous two values and take the average of it. Because there are no more previous values available, the first values are going to be nothing. So this 2367.03 is nothing but the average of these two values. And this value will be the average of these two values. And the average of this one becomes this. Like that, we will at any given point of time for a 2 period moving average, we will be considering the previous two values only. Similarly, for 3 period moving average, it is the average of the three values will be gone into this. And the average of this, the first three values will be gone to this. So similarly, for 5 period, 10 period, we can take n number of periods moving average. Let us say there are totally 10 values and we are taking 10 period moving average. That is nothing but the actual average itself. Now, there are few other terminologies that we are going to find. One is mean absolute deviation, which we identify, which we studied in QT, and mean square error, which also we studied in QT. Another one is mean absolute percentage error, MAPE, mean absolute percentage error. So how to calculate this one? MAD is nothing but average of errors. So first we identify the error, the actual minus forecast. So we are considering for 2 periods. This entire calculation is taken from the 2 period one. So the difference between this, the actual minus forecasted value, is the error. You can see the formula also over here. Okay. So sign is ignored, and similarly we have calculated the error for all these values. So the average of all these values is the MAD, mean absolute deviation. This is the formula also. Average of H5 to H22. So from this to this, the entire value. Similarly, the next step is to identify MSE, mean square error. For that one, whatever is the error we have taken, that is squared into this. So this is nothing but error square. So first we identified the error square, and then this is sigma of all error square divided by n minus 1. So while calculating MAD, we will be considering n. While calculating MSE, we will be taking n minus 1. But we will be considering square of all the errors. So over here there is some calculation wrong, but this is the wrong value, but this is the right value. So actually this is the sum of all these things divided by 22 minus 6 was taken, but that's not the correct answer. It can't be 18 because there are totally 18 observations over here. If we see, so when we have to do n minus 1, it has to be 17. So this is the actual MSE. Now coming to this one, what we are doing is error divided by actual into 100. This one, we are taking the sum divided by n. So we already calculated the error and we already know the corresponding actual value. So again, sign is ignored. This error divided by actual. For that one, we have calculated the multiplied by 100 and all that, divided by n observations. We are summing everything up and then calculating the average of all that value, that is mean absolute percent error. Since we are considering the percent, we are calculating the mean absolute percent error. So whatever might be the method through which we are forecasting it, MAD, MSE and MAPE can be calculated. Next method of doing is exponential smoothing. In case of exponential smoothing, this alpha value is given to us. Okay, alpha equal to 0.34. So the way of calculating the forecasting value is nothing but actual into alpha plus 1 minus alpha into previously forecasted value. Let me put this way. Alpha into y. Y is nothing but the actual. Y actual plus 1 minus alpha into y forecasted. This is forecasted value of the previous period. So using this method, the first one is going to be absolute copy. There is no calculation over here. And coming to this value, we are considering 500 into 0.34 plus 500 into 1 minus 0.34. But since both the values are 500, this value is also going to be 500. Now, coming to this value, 350 into 0.34 plus 500 into 1 minus 0.34. 350 into 0.34 plus 1 minus 0.34 into 500. Similarly, all the values are calculated over here. So, actual value into alpha plus 1 minus alpha into previous forecasted value. Again, as I said, we are calculating the error and the square error and the percentage of error to calculate the MAP, MSP, and MAPE. So using these values, a graph is taken, but to understand the pattern and everything. But otherwise, this method is called exponential smoothing. Next comes the trend analysis. So this is nothing but the regression model that we have taken previously. Based on the observation, we are going to plot a graph in linear method. So using the x and y coordinates, we are going to plot a graph, and then we are using this equation. Okay, this is the linear equation. It can be linear, it can be logarithmic, whatever suits best for us. Usually we go for linear equation, and for this linear equation, now we identified what is the relationship between the x and y values. We can forecast for the rest of the values. Just for x equal to 16, substitute the 16 value over here and then get the y value corresponding to that. So the same values are being plotted with using different equations. One is logarithmic equation, one is linear equation, another one is non-linear equation. Like this, you can use any method, as I said, but we are going to substitute the value x and then get the corresponding y value. And we already know that r square, anything which is closer to 1 is the most relevant one. So this is another method of forecasting the values. I think that's all.